Hello viewers. So as a sequel to my critically acclaimed how to make a cup of tea video, I've decided, well, to make something else. Now, having actually just drunk a cup of tea, I am really fired up to make this. And I did fail once before. That was, I tried making crystals, it turned into powder. So, you may have noticed I mentioned the word crystal. What am I making? Well, sodium chloride. I know. I'm stepping it up a notch this time. And while I can't really use that in a cup of tea, because one, it would taste frankly quite terrible, and two, it's not food grade acid that I'm using, so it would probably kill me anyway. So having thrown out the previous run, which I wholeheartedly regret because I don't think I took any pictures of it, with continuing with the second run, which is hopefully going to go a little bit better. So I'm in the lab, which is, it's a garage. There's stuff here. There's bloody slug killer. However, there's also a big lab thing set up on a pasting table. Yeah, I've really been resourceful here, and I will show you that. So, as you can see, there is the lab in all its glory, or lab. So we have a hot plate right here with a stand on it that I don't need. It's simply there for effect. Also, before I get into it, I should probably mention the PPE. So I'm wearing these nitrile gloves, these goggles, and this mask, and a lab coat. Now, 3 of those are required, I would say. One of those is for dramatic effect, although we won't admit that one. And 3 that are required are these gloves, this lab coat, and these goggles, because this stuff right here, not very nice to get on your hands. Hydrochloric acid. It's corrosive, it has the warning label right there. So you might be wondering, why am I handling it? Because I have really irresponsible parents. We also have deionized water, because distilled water was, well, it was more expensive. So, just put that back down there, because we don't need it right now. We have some beakers, many beakers. Some of them were being washed from when I failed to make it the first time. And we've got a measuring cylinder, which still has some sodium bicarbonate on the outside, but the inside should be fine. I'll just pour that out on the desk. It's water. It's fine. I neutralised any acid that I used last time. Moving on, we have a teaspoon that is never going to be used in making cups of tea ever again. I know it's quite sad considering this was a teaspoon, now it's a chemical spoon. And finally we have this glass funnel. I don't really know what to say, it funnels fluid. And we have on the floor baking soda, bicarbonate of soda, sodium bicarbonate, filter paper, and litmus paper. The litmus paper is supposed to be useful here. So, there are 2 methods I can take, and the first time I tried it, I completely messed it up. And that was grabbing a beaker, this one's not quite clean, I should probably wash those off again. Grabbing a beaker, grabbing your deionized water, and just pouring some deionized water into that. Now, that's harder to get it right because you can add an excess of hydrochloric acid and just send it down to pH 1, which is not something you want to do. So what we're going to do is this is a bit more wasteful with the acid though. If you take hydrochloric acid and pour it into this and then slowly add the sodium bicarbonate, you should finally get, there's bits of wood shaving in that. Now, I have a dilemma. Do I want to waste acid or get it wrong again? Now, I've chosen to get it wrong again, so I'm going to take this water, deionised water. It's just water, it's ACS grade, you can drink it. I'm not going to, but you can. Got a 600ml beaker. We're just going to pour out about 200ml. I'm doing this near the centre of the table, even if it's not well framed. Mostly because if I do it further away from the centre, you can't actually read the volume properly. This table does slant inwards. Yeah, we'll just pour out some water. Actually, we'll go for about 150, mostly because I've literally got it dead on 150. Well done me. We're not going to need that for a while now, so we can take our baking soda. That's the reason we've got a teaspoon here. We're going to try to add this in excess. Well, I say try to, we are going to add in excess. So we'll take this, take probably another teaspoon. No, I should probably dissolve it all first. We're not using warm water because I'm a bloody idiot. We'll just stir this until it wants to dissolve. Oh, my goggles are steaming up, that's not ideal. No, I shouldn't have done. That's really not ideal. But it is what it is. I'm going to just go defog my goggles real quick. Be right back. Hello, I'm back. I have defogged my goggles. I'm going to keep stirring this now until we get a colourless solution and as much sodium bicarbonate has dissolved as possible. And I do see wood filings. That will get filtered off as fine. So now this is in excess, so just grab some filter paper. I'm going to filter into this conical flask. It's quite hard to just get one of these out, especially when wearing gloves, but I will try, and almost got it. Yeah, I managed to somehow get one. Well done me. Right, so what we're going to do next is stick a funnel in here, fold the filter paper into quarters, like so. Probably that quicker, but less precisely. And then we're just going to take one of the little divisions in here. We're going to open it out. We're going to make sure it's folded down properly as well. And then pop it in here. Can just use cotton buds, that works fine. But I fancy and decided to use filter paper. We might need some of that laser sort of up there. Right, so we just pour it in a bit at a time and it will filter through, and as you can see it's coming out in the bottom. That wood shaving that was floating around in here will also get filtered off. So while we're waiting for all this to filter, we can put our hydrochloric acid into a measuring cylinder. So here's our acid. We're going to just undo that. You want to be very careful with this, mostly because it is hydrochloric acid and it is corrosive, like I previously mentioned. So I'm just going to pour that in carefully. Anything we don't use, we'll just get poured straight back into this measuring cylinder. Sorry, not measuring cylinder, straight back into the jug. And also, I'm going to clean the outside of that because I have realised that there is hydrochloric acid on the outside. That's not ideal. There's a small container as well. This is the boring side of chemistry, cleaning up your own mess. So just put a bit more through here. some of it may make it around the filter, that's not ideal. But ideally it doesn't. And just the last bit of water. See, I would do some more washings of this, but I'm really lazy. Also, there's no sodium, there's nothing on there. So, once all this is just filtered, which the last bit of filtration always takes the longest, it feels. I know, it doesn't actually, but that's how it feels. But when it's all done, we will be able to do cool things, says me. Now that's done filtering. We can take that out. We can actually just stick this in our beaker. Take the filter paper out. We don't need that anymore. And now I have this nice, hopefully clear solution, which it is. So now we're just going to use this beaker. We're going to pour it into here. And this is the fun part, where the reaction actually happens. So we've got a hydrochloric acid. Now, if this was just water, it would be a bit of heat when I dilute it, but nothing would really happen. Watch this. Also, I need my pH paper actually first. So we'll test the pH of this solution, just as a little comparison, because the folks on YouTube love comparisons. And this solution has a pH of around 9 or 10, maybe even 8, because sodium bicarbonate isn't that alkaline, but well, it doesn't form solutions that are too alkaline, which means you don't need really strong acid to neutralise it, but we do need this hydrochloric acid because we're making sodium chloride. So we pour a tiny bit in at a time, and you get a nice bit of fizzing. That is that's the reaction that releases carbon dioxide gas. We're actually going to put it on this little. Going to put it on the magnetic stir and hot plate. Drop the stir bar in. Yep, and that should react everything a bit quicker. So we add a bit more HCl. Get a bit more fizzing. And once again, this mask is steaming up. I will go clean this off again so I can see. Seeing is important in chemistry. Vision is very important, hence why you wear these goggles. Anyways, we'll add a little bit more. I believe this reaction is exothermic, I'm not entirely sure. So we're getting to a pH around, we're still around 8, which is not what we need right now. A pH of 7. So this does bubble like crazy, you know, all the CO2 gas. If you touch the beaker, it should be warm to the touch. And we are at a pH of around 7. So that should all be reactive. However, as I'm not entirely sure whether that's really from stirring, I turn it down. As I'm not entirely sure whether or not this is fully neutralised, I would actually, if I had a pipette, I would have taken a small sample of that. However, I do not, so oh well. What can you do? So, provided this is theoretically just sodium chloride solution, you need to make sure there's no potassium, not potassium, sodium bicarbonate. So I'm not sure if I want a tiny bit more of this. Because we need to react everything in here. Obviously I don't want to be boiling off hydrochloric acid later, that would not be very fun. Now we can assume that there's basically just trace amounts of sodium bicarbonate left in this, and I've messed it up and the solution is going slightly acidic. Maybe around a pH, it's around a pH of 7, that's perfect. Right. So now what we can do is we can turn the heat on and start boiling this thing off. And the only real issue is you can't actually tell what temperature it is. I have to kind of assume it's a temperature that's workable. But that should start boiling, and I will leave this to it.